let me introduce my next guest here. So we have Brian Goetz from Oracle. He's the Java language architect. Hello, Brian. And that's a really cool bar that you are virtually in.
Yeah, I got my my beer. It's just there you go. I got the beer you said.
I love when it does that.
We're all set.
Ah, good. You're better off than I am. I did not bring a beer with me to work because I'm in the office. So, all right, great. So listen, Brian, let's have you introduce yourself briefly. So again, Java language architect. Tell us what you do as your day job there as the Java language architect.
So, oh my God, so many things. Primarily, my role is charting the future of the Java programming model. That includes the language and also the core libraries. Any given day, I could be doing scribbling at the whiteboard, trying, I could be prototyping an idea. I could be going to conferences, telling people what we're doing next. I could be doing various internal advocacy for Java inside of Oracle. So no 2 days are the same, but primarily at the end of the day, my job is to figure out where Java's going in the next 5 to 10 years.
So why don't we just start, first of all, I know this is kind of a little bit of a wide open question, but why Java for a beginning programmer today or someone entering the development world?
Yeah, so if someone's going to learn a programming language, they want to learn something that's useful, something that is, that they're going to be able to apply to whatever they want to do next, something that has good tooling, such as something that has a rich ecosystem, something that they can find resources on how to learn it. And Java ticks all of those boxes, right? That Java is one of the most widely used languages out there. So if you learn Java, you're already, have a step up on a lot of programming jobs. There's lots of books, there's conferences, there's great IDE support. It's an industrial strength platform. So it's really something for everyone.
And now in Oracle here, so Oracle is obviously the shepherd of the language. They move it forward. You've got a community as well. You've got companies that are involved. How do you balance those things to move the language forward?
Yeah, so in almost all projects, especially in open source projects, the work is done by people who show up, right? And for something as big and complicated as Java, it's not something that is easy to participate in casually, right? Even a simple seeming language feature might be hundreds or even 1,000 hours of expert time and analysis before we figured out, okay, we know what to do, we know it's the right thing, we know how to do it. And so for big complex projects like Java, showing up often means some big company is paying for it. And many of the people who work on Java are employed by Oracle, but surely not all. There's lots of them at IBM and Red Hat and Intel and and Google and other big companies. And so it's really Oracle is the biggest contributor, but that's how it is today.
Sure. And I want to kind of illustrate that briefly. I know you gave a talk for us a while back at one of our ETEs about a little bit of a peek under the hood at Lambda when it first came out. Lambda was another one of those examples where there was like an obvious way to do Lambda or a couple of obvious ways to implement Lambda in Java, but you ended up choosing something a little bit more, it built on some of the features that were released in Java 7. Can you kind of encapsulate that briefly to show kind of the things that go into deciding how to move forward with some technology?
Yeah, so Lambda was was a very interesting experience. That was like the first big language project that I worked on. So it was really trial by fire. And at the same time, we knew that in some sense it was our last chance, in that coming off Java 6 and Java 7, when things were kind of a bit of a dark time for Java, where Sun's commitment was waning and Oracle hadn't yet stepped up, people were wondering, oh, maybe Java's had its day. And we sort of viewed Java 8 as, this is our opportunity to prove to the world that we can teach this old dog new tricks. And so there were a lot of proposals of how to do Lambdas in Java, many of which were in the category of what I call, why don't you just? right? And
Right.
there were so many, why don't you just do this suggestions? And the insidious thing about why don't you just is the word just seems so innocuous, but really you find it in sentences where the thing that comes after just is something that is actually not very sensible, and you're trying to make it sound more sensible by putting just in front of it. And there were a lot of aspects of that, and so we looked at it through the lens of not how do we add lambdas to Java, because there were 100 ways to do that, but how do we do that in a way that 10 years from now we don't have regrets? We don't say, oh, that was really nailed on the side, and you can think of it as, imagine you're like, building a building layer by layer by layer. You want each story to be perfectly smooth and flat so that you can build the next layer on top of it. As soon as you build some irregular, gouty shaped chimney on the top, you're never going to be able to put another layer on top of it. And so, one of the big concerns that we have when we're doing any kind of language evolution is not just, does this meet the short-term needs, but is this going to leave us with a nice smooth surface to build the next 10 stories on?
So then let's talk a bit about the Java community process in general, because that's kind of like driving a lot of the changes. They go through the process, they go through the proposals. Talk just a little bit about how that works for working new features in the language.
Yeah, so we actually have, strangely enough, multiple overlapping governance models. So we have the JCP, which was the Java community process that Sun started in the late 90s, which is the process by which the specification is ratified. But about in the last 10 years, we've moved almost all the innovation into OpenJDK, which is an open source project for which Oracle is the lead, and is a much more inclusive process. All the work is done in the open, people can just show up and participate. And so the JCP was an appropriate governance mechanism back in the bad old days when everything was done behind closed doors, and the Oracle and Sun and IBM and HP guys would get in a room and hash it out and then come out with, and here's our specification. And when we started to move away from that world, we realized that the JCP process was not the right process for for a more inclusive approach. And so OpenJDK has its own process called the JEP process, Java Enhancement Proposal, which is designed to be much lighter weight, much more transparent. But these are mostly processes for dotting the I's and crossing the T's. The real meat of it is figuring out what the right thing to do is. And, that's what I spend a lot of my time doing. And, if you look at a big feature, you'll see the early write-ups that are just trying to capture what the moving parts and the goals are. And, as time goes on, our understanding of what we're doing becomes clearer and gets reflected in a more confident draft of, and here's what I think we should do. And you can sort of watch that evolution go by, because it's all happening in the open.
So there are different projects in the OpenJDK, right? They're kind of focus groups or projects. And so I wanted to see if we can highlight a couple of those. So, the ones that I have listed are going to be like Project Loom and Project Amber and a few others. Why don't we start with Project Amber? Amber's, I think the main feature of Amber, if I remember, is like the pattern matching, correct?
Pattern matching, records, sealed types, a whole bunch of little goodies.
Right. So you were talking to me when we were pre-interviewing for this about like the concept of making a feature that might be a large overall project feature, but releasing it over small periods of time.
Yep.
Talk to me about like how regular expressions, for example, on pattern matching, I should say, sorry, and changes along those lines go through the JEP, through these releases.
Yeah, so being able to break up a big feature into multiple smaller features is something that we've only recently learned how to do, and in some sense out of necessity, right? So about 2 years ago, we shifted the way we deliver the JDK from these multi-year feature box releases where, at some point we say, JDK 8, the driving feature is going to be Lambda, and we're going to ship it in 2.5 years, and then we're always wrong about that, because the real world. And we switched to a model of time box releases where we ship like clockwork in March and September, and we work on lots of stuff in side repos, and then when something is ready, it books a ticket on the next train. So having more frequent delivery vehicles has allowed us to scope down things into, well, we know we want to get to here, but between now and then, we can sediment out this little aspect of it, which is useful on its own and also a stepping stone to where we want to get to. And pattern matching feature is an example of one that we probably will have broken up into maybe 4 separate deliveries by the time it's all done. So we previewed the first of them, which is simply type patterns and instance of, which allows you to fuse the instance of and the cast, which is a common annoyance, but not super exciting, powerful. It's it's a little nice thing, but it's also allows us to start introducing the basic concepts of what is a pattern, and then we can introduce more kinds of patterns, more places in the language where you can use patterns like the switch statement, etc. So and we've actually been able to sort of reorganize what we think is the second, third, and fourth installments as we've understood the process a little bit better. So we knew what the first one was. We had a guess about what the second one was. Turns out that guess was wrong, and that was better as the third one. And that's fine. We were able to adjust that on the fly.
How will you react to this statement? Move fast and break things.
So
I'm just testing here.
Yeah. So I'm not a big fan of breaking things.
Yeah.
That it's one thing if you're breaking your own thing, but as a language steward, everything I do has the potential to break everybody's code. And, I don't really want to do that, right? Breaking people's code or breaking with compatibility is breaking the promises that you've made in the past. And, you don't get very many chances to do that before people stop liking you. And we want the investment people have made in Java to remain valid, so that they've invested both in writing code and learning concepts, and we want to be building on their past investments rather than invalidating their past investments.
So the reason I brought it up is because you have the concept of previews and early access kind of settings that you can flip on in the flags. So, talk a little bit about like how you're going to be releasing these things. If you're not 100% sure about how they're going to end up, what's the general like life cycle of those? How long do they usually stay? There was a question for someone here. How long for a preview feature to be incorporated or maybe removed, what have you?
Yeah, so when we had these long feature box releases, we were pretty confident that we would be able to get enough feedback and have enough time to think about things during the course of the release. So, and we knew that at the end of the release, the concrete would be poured and we would have to live with that forever. When we shifted to a shorter time box model, we realized that we needed to bake a little bit of extra time for getting feedback into the process. And so we invented this notion of preview feature, where if we have a feature, I mean, if it's a trivial thing, we don't need to preview it. But if there's any concern at all, what we'll do is we'll put it into the platform as a preview feature. And that means it's a signal that this feature is coming. It's mostly done. It may be 98% done, but not 100% done. And it may be, become permanent in 6 months or 12 months, not 5 years, and it gives us an opportunity for people to try it out, give us feedback, and allow us to make changes based on feedback or based on what we figured out since the time, we started. And I would say, the norm will probably be that a language feature will preview for 2 releases, which is 1 year. And so we've seen, for example, type patterns and instance of first previewed, and then we're re-previewed, and then in the upcoming release will be final. And we kind of expect that to be the norm, although it's not a guarantee. And same with text blocks. Text blocks will be final now, as well. And it's possible we could withdraw a feature after preview. We don't expect that will happen because the bar to previewing is still pretty high. But this way, it allows us to get feedback on the last few percent.
Okay. So we talked about a little bit about some of the things in Amber. I know records are just now a nice feature that they're ending up in JDK. Was that JDK 15? I believe it is.
So they previewed
Or
14,
14
and then again in 15. They hopefully they will be final in 16.
and 16. Okay, all right. Some other are there anything other things coming out of Project Amber that are of note that you're looking at in the near term?
Well, so the overall theme of Amber is what we call right-sizing language ceremony. It's all the little things people complain about in Java.
Mm-hmm.
So out of Amber came local variable type inference, or VAR,
Right.
pattern matching, records, sealed classes, text blocks. With features like pattern matching, like I said, there will likely be more than one installment of them. So certainly more of the same coming. One of the things that the sort of old style release model, where we had these long running releases, ended up doing to our detriment was we were always so focused on the big thing that was the release driver that smaller things kind of got the short end of the shuffle. And so
Mm-hmm.
we wouldn't do features like local variable type inference because we were worried they were going to compete for attention with something like Lambda and risk putting the schedule at risk. With the 6-month releases, it's a lot easier to have a balance of big stuff and small stuff going on. So, you can think of, Amber as being sort of one train that's proceeding at its own pace, and then the longer running things like Valhalla or Loom or Panama are, bigger trains on another track proceeding at their pace.
Why don't we talk about Valhalla next? So you're looking at things like value types and some dealing with some of the generic issues. Why don't we talk a little bit about that? So what are the benefits of generic specialization and value types coming down the pike?
Yeah. If you look at how if you look at how the Java object model works, as it was given to us in 1995,
Yeah.
you sort of want to believe everything is an object. That was the goal, and that was object-oriented nirvana circa early 90s, right? But it's not actually true that everything is an object. You've got these 8 types off to the side, in float, long double, that are not objects, and they're different from objects in every possible way. And that is it was a forced move back then. We didn't know how to do anything else, but that has been the cause of a lot of friction and sharp edges and gaps that people fall into. Certainly, when I was doing the streams library, where we had to have hand specialized code for in-stream and long stream, and then all the ancillary types like in function and such. That added so much to the cost of development, the constraints on the design, et cetera. And that's just pure friction that gets in the way of people effectively using using the language to do what they need to do. And so we sort of have 2 big goals for Valhalla. One is unifying the type system. Get to a point where truly everything is an object, where truly you can generify over everything and not have to worry about falling into the gap between objects and primitive types. And so that's a pure programming model benefit. And then the other benefit is performance. If you look at how objects are laid out, because every object has object identity, the runtime is essentially forced to represent an object reference as a pointer. So if I have a boxed integer, a Java lang integer, in memory, there's going to be a node that I've allocated in the heap that has a 2-word object header and then an integer in it, and I'm going to refer to it by a pointer. And that means to get to that data, I have to traverse the pointer, maybe incurring a cache miss. I'm using 60% of the memory that I'm using is for things like pointers and headers rather than for data. And so there's a performance story of what if I could write my own primitive like classes that didn't have object headers, that could be inlined into data structures and flattened into arrays, and integrate that into the object model in a uniform one-size-fits-all way. And so that's sort of the vision for Valhalla. And it's not a small project. In fact,
Yeah.
I first talked about Valhalla at ETE in 2014.
Yep.
Which was around the time we started the project. And when we started the project, James Gosling said to me once, so we were on a panel at Java 1, and he turns to me and says, So Project Valhalla is like the coolest thing ever. I totally wanted to do this, when we started, but we didn't have the time. But you do know, Brian, that you've like just signed up for like 6 PhD theses, right?
Type theory and everything. Yeah, right.
And I'm like, and I was thinking, I was kind of hoping it was like 2, but boy, James is a smart guy. I'm not going to contradict him. And well, what do you know? He was right. So let's say we're 4 theses into this project, which is to say, I think, we've rounded the curve and we're on the downhill, but there's still plenty of work to do. I think it's going to be really cool.
That's awesome. And the other one that's really seems to be really interesting to me is Project Loom. So Loom seems like another really, I guess it's somewhat near term. Am I correct in thinking that it's closer along than Valhalla is? Tell everyone what Project Loom does.
Yeah, so Loom is about rethinking the concurrency model by not rethinking the concurrency model. Java has, one of Java's advantages as a language is that it has a built-in concurrency model that's not just a library that's stapled on the side like pthreads was, in the 90s, but really integrated into the language. And that has served us pretty well. One of the problems with threads is that they're expensive. When you say new thread, the JVM goes out to the operating system and says, hey, make me a thread, and has to allocate tons of memory for stacks and data structures. And so you can allocate hundreds or maybe thousands of threads, but you can't allocate millions of them. And so that becomes a scalability bottleneck if you want a system that is going to be able to take a million concurrent connections. You can't give each one its thread, even though giving each one its thread is like an awesome programming model, right? Because what threads give you is the illusion of sequential code. You do stuff, and if something blocks, well, that's fine. But the great thing about sequential code is, as humans, we can read it. We can know what it's going to do. We can put a breakpoint in the debugger and say, when you get here, stop, right? And so Java developers now have this choice, which kind of sucks, which is to use the easy-to-use programming model, which is sequential threads, but eat the scalability problems, or use something like reactive, which is much more scalable, but has terrible problems as a programming model, because essentially a reactive library is reinventing all the things that the language is supposed to do for you, like control flow and all of that, and like good luck debugging reactive streams and things like that. And so what Loom says is, well, what if we could make the thread abstraction in the runtime cheaper? Then you can just keep the same programming model that you've always had, and the same debugger and all the Java libraries that just assume that everything is blocking, and you can have millions of them. And it kind of sounds like a free lunch, but we've been able to do it. And you're right that it is sort of both a newer project and something that is relatively short term on the horizon. It's something that sort of came together very quickly, due to the heroic work of some mad geniuses, and of which I'm not involved in that. I'm just watching on the side. And I think it's going to be a real game changer. And I think like the hidden thing about Loom, and people are not going to like this when I say it, is we're going to discover that reactive is a transitional technology. We're going to discover that we thought we liked reactive, but actually it sucks. And that, it was just one of those, the alternative was worse, so it seemed good. But when there's a better alternative, I think people are going to drop it like a hot potato.
I think if you look at a lot of the functional languages out there, that model, the kind of like the reactive chaining operations on each other model is kind of one of the ways that you can kind of envision. And I'm specifically thinking like RxJS and JavaScript.
Yeah.
I look at the functional reactive model, I look at that and like, wow, they're almost the same concept all the way through. Do you find that now, because there's kind of two sides of this coin. One side is that other languages can probably inform you. Like, so one of our questions came from someone asking us, Scala dev here, would like to get your opinion on various features of Amber might end up looking like or not looking like what we've seen in Scala. So Scala or other languages like maybe Clojure or what have you informing Java. But then you've just gone the other direction and said, you know what, we've been informed by those languages and we thought we could probably do it in a more Java-like way.
Yeah. So we watch what's going on in all the languages, right? And there's some really interesting and innovative work going on in other languages, and that's great because we view all of those other languages as our laboratory, right? So Scala is not under the compatibility constraints that we are. They are free to innovate much more rapidly. They're free to break their users' code over and over and over and over again, and out of that came some things that we thought worked really well and some things that we thought didn't work so well. And we're able to look at it and say, well, that thing that worked well, let's see if we can adapt that into Java in a more Java-like way. And I think, like, coming back to what we were talking about earlier, which is pattern matching. One of the things that Scala has that's very nice is they have nice pattern matching. But if you if you read like the original Odersky paper about called pattern matching with objects, it was really innovative at the time, because at the time everyone thought pattern matching was really a functional thing. And it was sort of the exact same time that Don Syme was doing the same things in F#.
Mm-hmm.
And so a lot of the people in the object-oriented community said, wow, that's really cool that pattern matching works on objects too. Great, we like that. But the way that pattern matching is integrated into the object model in Scala is a little bit superficial. All patterns are static. You can't have patterns that are members of objects. And one of the things we realized when we looked at, well, people like this part of Scala, well, we can actually not just bring that into Java, but bring it in a much deeper, more organic way. And I don't think we could have done that if it hadn't been for the experiments that other languages did that tried various things. And, we get to stand on the shoulders of giants, right? So, I mean, some people are very proprietary about their favorite programming language. And they say, oh, you stole that from Scala or Kotlin or whatever, to which I say, oh, and did you steal infix arithmetic from Fortran? Right? This is not like a property thing. This is
Right.
a spirit of scientific discovery, where each discovery informs discoveries that come after, right? So yes, we draw inspiration from everywhere we can, and there's lots of things that I know we'll never be able to directly bring to Java, but we can still be inspired by. For example, like I do a lot of my side work in Haskell because it's a great language for prototyping ideas. And some of those ideas I'd love to see in Java. And you can't, of course, bring them, they would want to bring all of Haskell with them, and that's a non-starter. But, sometimes you can bring a little bit of the inspiration that you got, along with the feature.
And because Java has, and you've talked about this in other talks too, but because Java has that very late binding and the when you're building and running in the hotspot, you can make changes to things and optimize there. Talk to me a bit about that. Like, so for example, Scala, I know a lot of work is done in the Scala compiler to write out bytecode. It's almost like a big macro language to a degree for some of this stuff, but you can do a lot more than that, right? So because you own the JVM, because you are the JVM, you can do other interesting things.
Right. So one of the things that we try to do, for better or worse, in the Java language is to stay aligned with the JVM. And that's more of an aspirational goal than a hard requirement, because if you look at how we did generics, say, in Java 5, that's where we started to depart a little bit from this nice one-to-one mapping between types at the language level and classes at the VM level. Scala has diverged quite a lot. And so if you look at the bytecode that comes out of a Scala program, it doesn't look very much like the source code it came from. And in part, that's just natural for the sorts of things that they want to do in their language. You see the same thing in a language that is not like Java, like JRuby, right? So the Ruby language has all kinds of assumptions about the runtime that are not necessarily a perfect fit for the JVM. And so the bytecode that they have to generate is pretty ugly. And sometimes it's not as fast as you'd like it to be. And so we try to keep the Java language aligned with the VM, by co-evolving them together. Maybe one of them gets ahead of the other a little bit, and then the other catches up. But we try to keep these things going in lockstep, because ultimately, the closer that you are to your translation target, the fewer weird things are going to happen.
So things like the fibers that you're going to be rolling out in Loom, right? I think we were talking about this. Maybe I'm wrong, but I think what you were alluding to was you write regular imperative programming with APIs, and those APIs behind the scenes either could do the fibers, or at a lower level, the JVM could potentially maybe optimize and kick off fibers instead of heavyweight threads. Is that what I'm understanding?
Yeah, and in fact, like originally, and this is a good example of sort of how the ideas evolve over the course of a project, right? So if you look at what was written about Project Loom when we started the project, it was about lightweight threads. Fibers are lightweight threads, and there was going to be a new API for fibers. And that made sense as this is our first attempt at thinking about it. This is how we would prototype it. And then,
Right.
like, as we went on, we realized that we don't need a new API, or we need almost no new API surface. A fiber is a thread. In fact, a fiber is a java.lang thread that just gets produced differently, and so we ended up calling them not fibers, but we're calling them virtual threads. And the reason
that's the new name.
That's the new name. And the reason we picked that name is it's a lot like virtual memory, right? So virtual memory, you have more virtual memory than physical memory. And then when you go to use, certain bit of memory, the hardware jumps in and says, I'm going to bind this region of virtual memory to that region of physical memory. And I may change that mapping later, but I won't tell you, right? And the exact same thing is happening with Loom virtual threads and kernel threads, where the runtime will mount a virtual thread on a kernel thread. Sometimes we call them dinosaur threads, and because they're big and slow and lumbering, and they've been around forever.
There you go.
And then later you hit a blocking point. We will separate those two things, and then we may remount that same virtual thread on a different dinosaur thread. So that's why we call them virtual, because the binding to the underlying thread is handled transparently by the runtime for you. And so originally, like I said, we thought there'd be this new abstraction in the programming model called fibers, and people would have to learn about fibers. And then we realized, no, people don't have to learn about fibers. The only difference is, when you make a thread pool, you have a thread factory that makes new threads, and you could stick with one of the old style dinosaur thread factories, or you could have a virtual thread factory. And that's the only place in your program where there's a difference.
Beyond that, they start, they pause, they resume, they die.
Yeah. Exactly. And but just much faster, right? But starting a virtual thread is just allocating an object in the heap. And so you can allocate millions of them. And there's a certain amount of cost to descheduling and rescheduling them. So there are some performance trade-offs. If you're building a web server, you're going to have to make some decisions about what to do. But that's what engineering is trade-offs.
Right. Also, there was another question here. Speaking of aligning bytecode with classes, are there any long-term plans to introduce generics to the bytecode?
Yeah, so that's a really good question, and this falls under the Valhalla story, and I think underneath, the question is really, are we ever going to get C# style reified generics? And I'm going to sidestep that and talk about another aspect of putting generics into the VM, which is, there's a lot of different reasons why you might want your VM to be aware of generics. One is layout specialization, right? If I have, a linked list of T, and I have cells, of type T, well, with arrays generics, all I can do is say, well, T is object. But if I know, for example, that I'm instantiating linked list of point, where point is a XY point with 2 ints, I would rather not take the object indirection penalty of having a pointer to a point in that cell. I'd rather just specialize the layout to have an X and a Y field and store that point value in line. And so one of the things that Project Valhalla is looking to do is to be able to do layout specialization for generics. Related to layout specialization is code specialization. That if I have code for a method in linked list of T, the code for linked list of int and linked list of string might benefit from type sharpening. And so if I'm able to split the code paths and say, yes, they're both derived from the same bytecode, but when you JIT it, you're free, the JIT is free or not to JIT separate versions for list of string and list of point, we may get different optimizations. So there's layout specialization, code specialization. Along with that comes calling convention specialization when the JIT generates code. And so there's all sorts of reasons why we might want to push generics into the JVM, even without C# style reified generics. Most people, they look at Java's erasure and they have this like immediate distasteful reaction to it. It's erasure is like the most misunderstood thing in Java. They look at it as this wasteful act of you had some perfectly good type information and you just threw it in the street as if you didn't value it, right? But of course, the cost and complexity of pushing that information into the VM is not trivial. So our focus for generics is much more about performance, layout, flatness and density, and better optimization. And if we can get some kind of runtime type awareness as a bonus, we'll be happy to take that bonus.
Let's take a little bit of a left turn here and talk about containers in Java. So from the beginning, we were talking about this earlier when we were prepping, from the beginning, Java is meant to, for server processes, live for a long time and really have memory management absolutely tight, threading managed well, no runaway processes, be able to work with it. But containers are different, right? You launch a whole bunch of them and you hope for the best.
Yeah.
How has Java changed some of the approaches or added approaches for dealing with container-based applications, and what will be important to someone who's just getting started in that?
Yeah, so when containers first came around, everyone said, wow, Java really stinks in containers. The startup is too slow and it doesn't respect like container memory limits or CPU limits or any of this stuff. And all the people who like love to write off Java as that dog has had its day, declared victory yet again over and over again. And the reality is that Java's runtime behavior is tuned based on what people do in practice, right? And so for many, many years, the style was you bought the biggest machine you could find, and then you put an application container on it, and then you put a whole bunch of applications in the same container, and the thing ran for months, before it was ever restarted. And so not surprisingly, most of the engineering and optimization effort for the Java runtime went into better long-term asymptotic performance, long-term stability, avoiding long-term heap fragmentation so you don't, eventually crash when your garbage collector, can't defragment the heap and things like that. And so Java got its reputation as being good for big, long-running processes because that's what people wanted to run and that's what we engineered for. But there's nothing that says that we can't engineer for other things. And so over time, we've done a bunch of things that have made Java better for containers. So now, for example, it does respect container thread limits and processor limits. And it's more aggressive about giving memory back to the underlying operating system when it doesn't need it. And we've been working on startup. So if you look at every one of these 6-month releases, 10, 11, 12, 13, 14, you see, some improvements in startup in each one of them. And it isn't necessarily dramatic where hello world goes from 80 milliseconds to 5 milliseconds, but you see it gets a little bit better each time. We knock a little bit off each time because people are running shorter running processes, and we don't want startup to be the reason people don't use Java. So where another thing that we've done for containers recently is the Alpine port. Right, so Alpine Linux is popular for running containers because it's small, and there's a port of Java to Alpine Linux, and so little by little Java is
showing itself to be a perfectly reasonable container-worthy platform. And are there things that a developer can do in terms of getting prepped for running Java in a container?
Yeah, so I think one of the things that they can do now is learn about the module system. So the module system was something we added in Java 9, and it was something that was coming for a long time. It was almost a little bit of a joke. It's like, are modules going to come in 7? Are they going to come in 8? And
Right.
the reason it kept getting pushed off is because we didn't think we were ready. We didn't want to pour the concrete on something that wasn't ready. So it was finally ready in 9, and it shipped in 9. And a lot of people mostly want to ignore it, and I can sort of understand the motivation of that. But if you're interested in running in containers, one of the benefits of the module system is it allows you to slim down the Java runtime to only have the stuff you need. So if all you need is the stuff in the core libraries and the JDBC support, you can use this tool called JLink to say, make me a custom Java runtime image based on Oracle JDK 15 that requires the modules java.base and java.sql and these 3 libraries I got from Maven Central, and it will go and produce a runtime that doesn't have Corba and all of that extra baggage along with it. And that's something you can put in a container that is going to make the JDK a lot smaller.
Wasn't there also some sort of a native build tool that was recently, like building a native binary? Didn't
Yeah,
that come in Java 14 or something like that?
it's not in the JDK. It's part of Graal VM. So,
Okay.
so that tool is called Native Image, and it's part of Graal VM. And what it does is it does an extensive build time analysis where it tries to find all the code that you're going to use, and by extension, all the code you're not going to use, and then it does a closed world analysis and builds a native executable that is driven only by the code that you're actually going to use, and is able to because it doesn't have to worry about dynamic linkage and dynamic class loading, is able to optimize calling conventions and do inlining and all of that. And so there's some trade-offs, just like there are for anything else. The native image compiler takes a long time at build time. So if you're doing rapid development, you probably don't want to do that on every build. It produces images that start up really fast. But the code it generates might not be as fast peak performance wise as what you would get out of a long-running dynamic compiler, because dynamic compilers have the opportunity to recompile things on the fly when they've made observations about your program. So so by moving compilation to static build time, you're getting a bunch of benefits, but you're giving up a bunch of things. And so for some things like short-running command line tools, it's great. For longer running things where you care more about peak performance, you might want to use a dynamic compiler and take the startup hit. And so we view that as it's one more tool in the toolbox, right? You know more about the characteristics of your application than I do. So you can fold that in with your business requirements and decide whether startup is more important or footprint is more important or asymptotic throughput is more important, and pick the tool chain that supports that.
Okay. A couple other things. We had a question around Java's sweet spot in the next 25 years. Of course, who can look that far, but we're going to throw it out there because it's a 25-year thing, right? So things like for Chariot, for example, we see some growth in Internet of Things devices and things like that, and data engineering. And he doesn't hear Java being front of mind for those things, even though it may be in the interior of some of these things, right? So where are the areas you see that being big areas that people are going to start embracing Java for that maybe they haven't in the past?
Well, so, of course, we would want people to embrace Java for everything. Right?
Of course.
But, we also recognize that, it has strengths and weaknesses, at least relative to, the current technology. One of the reasons why we invest in big projects like Valhalla and Panama is because we view those as enablers to moving Java into some of the areas that it might not be perfect for right now. So as an example, let's take, data analysis, machine learning, et cetera. People like doing that with Python. In part because Python's like MATLAB, right? It's really easy to get in there and interactively try things and try something else and pull in some data from here and massage it and do that thing, and that's great at development time, but it's kind of lousy at deployment time. Java's strength is at deployment time, rock solid deployment story, excellent performance, etc. But a lot of people are skeptical that of whether Java can be, the right platform for, for data science. And one of the things that, projects like Valhalla and Panama, are doing is they help shore that story up, right? So, we talked about more efficient layout of data in memory. Well, if you can lay out your data more efficiently, you can work with bigger data sets. Right? If you can flatten out the layout of data in memory, you can get much better performance, when you're doing data analysis. So, these general things like Valhalla are really like Swiss Army knives in the sense that they're good for everything, including a lot of the things that are up and coming that are really pushing the, the boundaries of the runtime. So, I think, what we hope people will start to say in a few years is, I didn't think Java was going to be able to do that, but, and a lot of those things I think are going to be powered by the sort of fundamental improvements that we're making in the context of Loom and Panama and Valhalla.
Okay. Here's another one, Java and quantum computing in the future. What do you think of that?
So, quantum computing has been like the next big thing for at least the last 10 things. And so, and I know one day it really will come, but
yeah.
It's hard not to be skeptical that, they've been talking about this since like I was in college, and that was a long time ago. And so I'm a little skeptical that that's something that we're going to have to worry about anytime soon. But I could be proven wrong. But I certainly our industry is certainly one of things come along that you didn't expect. So I could be wrong.
All right. And then early on when dynamic languages were getting really popular, I know that the very first one that people really took to back, and I'm thinking 2006, 2007, was Groovy.
Mm-hmm.
Groovy being a simpler syntax for Java. And I think Lambda has cleaned some things up, and there's some other things that have happened. Do you see yourself at some point paring the language down in terms of the required things in the language to make it a little less verbose?
Well, so I don't think we can pare it down in the sense of removing things because we would break people's code.
Or making them optional, perhaps, right?
But certainly we can provide better ways to do some of the same things, right? A lot of the Ambra features are about doing more with less code, right? So records, for example, they don't replace all classes. We can't say we're deprecating classes, it's just records from here on in. But when you have a class that's suitable to be a record, you're really happy you have it. So a lot of the little things that we can do that are filing down the rough edges, are things that had been requested in the Java ecosystem many years ago, and for whatever reason we didn't do them at the time. And then other languages came along, like Groovy or later Kotlin, saying, "Well, we'll do those things." And some of those we've looked at and say, all right, well. Now that we do have some budget for smaller features as well as big things, these three things seem to be really popular, and there's a good way to fit them into the language. So sure, we'll do those, right? So we'll pick carefully, we'll do a few of those. I think Groovy in particular, though, has largely had its day. Groovy was pretty popular in its time, but the context of the time was also one when Java was maybe on the wane, or perceived to be on the wane, because Sun wasn't investing. They were too busy going out of business. And so Groovy tried to step into that void. Then we started reinvesting in Java again. And some of the reason to use Groovy just went away. And then later Kotlin came along, and offered people a lot of the conveniences that Groovy offered them, but in a more Java-like language that was statically typed. And so the people who were inclined to pick a language based on syntactic convenience were going to prefer Kotlin over Groovy, and that's fine.
Yeah, we run into people doing Spring, for example, in Kotlin, just because it's, Spring is getting nice and terse now, but Kotlin makes it even more terse to work with, less actual code. Okay. Let's see, we have time for a little bit more here. So in terms of other Java projects and JEPs coming down the road, what do you see as some of the really interesting ones that you're keeping top of mind?
Well, so like I said, I think Valhalla is going to be perhaps the biggest change to the platform, that we've ever done.
Mm-hmm.
We're hoping to keep the impact on it, to users somewhat minimal, but it's probably like when generics came along, right? You had a great compatibility story, a great story for migrating from old code to new code, but you had new things to learn, and it took people a while to learn those, and I think that is going to be, a real game changer, both in terms of programming model and performance. But I think it's going to take people it's going to take us a while to finish it, but it's also going to take people a while to really, really understand the benefit. One of the other things that's coming a little bit sooner that's kind of cool is Project Panama. And this is about rebooting Java's relationship with native code and native data. So Java's always had support for native code. There's always been JNI, but like anybody who's tried to use JNI has learned this has to be your last resort because it's painful.
Yeah.
It's painful, it's unsafe, it's slow, it's like, it really ticks all the boxes in the wrong way. And so Panama builds on compiler technology that we've developed, in the last, mostly in the last 10 years, specifically method handles, and allows and provides better tooling where you can take this tool, you can point it at a .h file and say, extract me a Java interface for that .h file. And it generates a bunch of Java classes that you can call like Java classes. And you can customize it to say, okay, for this C type, I'd like you to map it to this Java type for me. And we'll generate code to do that. And then at runtime, there's a dynamic binder that produces method handles that are bound to native entry points that are much more effectively optimizable by the JVM than JNI code is. And so, something that used to be slow and unsafe and error prone becomes easier to use and safer. And so the overhead of, I want a library for this, but I can't find one in Java, but I found a great one in C. It used to be you had to really want to use that library to be willing to do what you had to do to use it from Java. And now it's mostly a matter of, you configure your tool and you experiment with it for a little bit, and now you can call it like it's a Java library. So I think that's gonna help a lot, because coming back to one of the topics you brought up earlier, which is innovations in things like machine learning. A lot of the interesting machine learning libraries, people think they're in Python, but they're not. They're in C++, right? TensorFlow is not a Python library. It's a C++ library designed to be wrapped by Python. And so, it's fairly easy to wrap other languages around TensorFlow also, because it was designed that way. And so putting good Java bindings around TensorFlow is a much faster way to get to a machine learning story that today's data scientists already understand than inventing a new Java machine learning library.
Speaking of, I was just going to say, there's even a REPL in Java, for example. I wanted to bring that up anyway. So people go into Python and they play, right? Or Ruby or Clojure, or what have you. But JShell, I wanted to bring up before we finish, there's a couple of newer tools. We have 58% of the people that are on this call or registered for this call were Java 8. And so there are, less people going into the newer JDKs. But in terms of tooling, that's like one of the big tools that people need to learn to use. Is there anything else they need to be aware of if they're just transitioning to 11 or 14, let's say?
Yeah, so JShell was something we added in Java 9, and I love it. I use it every day. Because if you have a Java library that you just want to try out and you want to open a window and start typing some code, you don't have to open a project in your IDE or anything. You can just open up the shell and start playing with it. And so I use that all the time. We also added it because that was part of the feedback we got from educators. That they said, the overhead of writing a Java program and
Yep.
compiling it and building it and running it, even though the IDE automates a lot of that for you,
Mm-hmm.
it just it added friction to the process, and students want this immediate feedback of I typed something and then this happened, right? And so JShell might have been a latecomer to Java, but it's a really nice tool. Another tool that people should learn about is JDEPs, which is a tool for analyzing dependencies in your code. Right. So like I said, we added the module system in Java 9. And in some cases, if you have dependencies on old out-of-date libraries, you may have issues getting past Java 8. But there's tools like JDAPs where you can say, well, go look at my application and tell me what I'm doing. And it gives you a nice little report that says, oh, yeah, you're dependent on this library, which is doing this thing. And, you're going to have a problem with that. So either you need to update that library or, what have you. And it makes it a lot easier to migrate from one version to another because you can run this tool to get an estimate of, well, what's my liability here? Is this a day, a week, a month project?
Okay. And then, so kind of like to wrap this up then.
Yeah.
So the biggest debates you have right now in the Java community, like what are the biggest, most thorny debates that you guys are all having right now on what you're going to do next with something? Because I know they're out there.
I'm sure they are out there, but they don't always make it to my desk. Make it to my desk are all of the form, why don't you, ...
Right.
Either, why don't you take this feature from my favorite language is the most common one. The second most common one is, why don't you give up and declare my favorite language the winner? And, but they're mostly why don't you questions that at least that I get. And as annoying as some of those questions are, especially when you hear the same question for the umpteenth time, that means that people out there still really care about Java and still want to use Java. So it's all good.
Right. And so the biggest thing we haven't really talked about in general about remaining relevant over the next 25 years, we've talked about, you're backwards compatible. You don't want to break things. You're slow to add new features, but not too slow now because you got a good release train going. Anything else? I mean, you've got a good community of people interacting. You've got the JEPs and everything. Like, is there anything else that you guys are trying to help figure out the path for the next 25 years? Like, and that's a completely generic and weird question, but yeah, I have to wrap up with something, Well,
like for a talk a couple of years ago, I took a look at, all the language changes we made, and took some code from Java 1.0 and say, okay, in 1.2 you could turn it into this, and then 5 you could turn it into that, and then 8 you could turn it into that. And it was really quite dramatic, that even though each of these changes was a small increment, you look back at the Java 1.0 code and you say, oh my God, that looks like a foreign language.
Mm-hmm.
How do you program like that? So the reality is expectations keep rising. And, we need to rise to those expectations or we're going to fall behind. And, the hard balance is moving forward at just the right rate so that we're rising to the expectations, but not making scary radical changes that are going to make people say, oh, this isn't the Java that I know, and run away and go do something else. And so, I think it's the keep teaching this old dog new tricks.
Great. All right. Well, listen, thank you very much, Brian Goetz, for taking this time with us. I think everyone got it. There's a really good feedback out here. One comment was someone, the same guy that was asking about some of the JDK generics is saying, this is the megamorphic inlining improvement by Vlad Urch paper.
Yeah, so that's the mini boxing paper. Yes, I've read that paper many times. This was a guy in the Scala community, who did an interesting experiment that turned out and did not work out as well as anybody thought it would. And that was actually an incredibly useful result because it told us this is a clever seeming idea that turns out not to be the right thing. So, you know, absolutely.
All right. So yeah, so everyone, if you check your emails, and also I believe it's in the chat here. Let me just double check here if I can get chat up and running. It's misbehaving for me here. There should be links to the actual happy hour, and we'll see you all over there in the either the Java space or the Philly Jug space. But thanks again.
Yeah, thanks, Ken.
Take care.
Yeah.
Mhm.